All right. Um, hey, everybody, and welcome to my first trial run of my first lecture about R and RStudio. I have been wanting to try out R and RStudio in quantitative methods for quite some time. I've talked with a couple people about it, and I have equal numbers of people saying, "Ooh, that's going to be very difficult for our students." And another equal number of people saying, "Oh, this is probably a good idea, but I'm interested to see how things pan out." So I wanted to do a trial run of a couple of things, a couple of lectures, and get some feedback on what people like about it, what people don't like about it. Send it to a few professor friends, send it to a few of my former students to see if it makes sense, if it's useful. So yeah, I'd love to get some feedback on this. Couple of things. One is I'm going to assume zero computer knowledge with these lectures because a lot of our students come in with very little computer experience. So I wanted to make sure that they are up to date or that they can follow along, right? So a lot of the books out there are go into things quite quickly that I think it might be overwhelming for students. So I wanted to very, very gently wade the waters of R. The other aspect of this is I'm going to assume a smidgen of statistics knowledge, right? I'm going to be teaching these statistics in class and then showing people how to do them in R afterwards. So hopefully people have some basic understanding of some statistics as we go through this. But those are kind of the caveats for this lab. All right. So first, I'm going to do the absolute basics of R and RStudio. And if you've had any sort of computer experience beforehand, some of this might be boring, and I apologize for that. But I want to make sure that everybody's on the even playing field in this class. So first thing that I want to talk about is why should we teach R, or why is learning R a good thing? Why is why RStudio? Okay, why not just based R? So I'm going to try to do some persuasion there and see how that works out. Then I'm going to talk about some very basics of RStudio. What's the layout of RStudio? And finally, I'm going to do some very, very simple stuff in R, just using the console before moving on to some other aspects of RStudio. So just some very, very basic math using R essentially as a fancy calculator in the beginning before we do some more important things. Also introducing some terminology that we're going to use throughout the lab, some basic computer science kind of terminology. So first, let's talk about why learn R, right? It's not as easy as SPSS, right? SPSS is a click and you click and it does the statistics. R requires a little bit of programming knowledge. So why put yourself through that trouble when there are some easier alternatives, right? Well, one advantage R has is it is free. All right. It costs no monies. Back in the day, when I was in graduate school, when I was an undergrad, the two major options, R was around, but really not that popular, were SPSS and SAS. And SPSS cost a lot of money. If you want a license for a year, it's about $1,000, if I remember correctly. So it's quite expensive. Even the student license is fairly expensive. SAS is even more expensive. The great thing about R is it's free. Okay, there's some other free alternatives, but this is a big advantage that R has. Another great thing about R is it is incredibly flexible. For anything to be put into some of the other statistic packages like SPSS and SAS, the company that owns that software has to make that change. So if you're familiar with some of these software statistics packages, you know that SPSS and SAS are sometimes slow to implement new statistics. They have a certain way in which you process data. The good thing about R is anybody can create some new R code. They could create a new R package, and that will be hosted on the R servers. And you can immediately download that package and use whatever that new statistic is. So a lot of quantitative psychologists, if they develop a new statistic, the first thing they do is create an R package, and boom, it's available for anybody to use, which is quite nice. All right, you don't have that lag time. These packages can go out immediately. There's multiple ways to do things in R. So if you don't like the way that this particular package does things, maybe there's another one that fits better for you. So R is incredibly flexible that way. Another advantage of R is that the graphics are particularly good. Again, I'm going to make the comparison with SPSS. SPSS graphics are not great. Not only are they not great, SPSS sometimes has trouble loading those graphics. And if SPSS is ever going to shut down, it's going to shut down when you're trying to do one of the graphs there. So R's very, very good at this. The graphics are top notch, and you can create journal ready graphics within R. Whereas I don't think anyone would ever use SPSS graphics in a journal article. All right. I mean, I wouldn't even recommend using them for a poster. Right? They're not great. Another great thing about R, and let me contrast this with some of the, we might say, more user-friendly statistical packages. So things that we might call GUIs. What is a GUI? A GUI is a graphical user interface. This is a statistics package in which you can click and drag things to make things happen. Okay, SPSS, 3 clicks, and you can do whatever statistic you want or need, which is great. But the downside is once you've made those clicks, once you've typed that data in, once you've selected a certain box, you might not have a record of that for the future. Now, some SPSS has syntax, which is great, but not every click you make in SPSS can be recorded. All right. R, everything can be recorded. This is great for reproducibility. Oftentimes with statistics, you do something and then you go off and do something else. You teach a class, you present a new project, and you go back to your statistics a week later, a month later, maybe 5 years later. When you do this, sometimes you might not know what it was that you initially had done when you were doing those clicks. With R, you put all that in the script, and so it's there for you exactly the same way that you did it 5 years in the future. So that's another advantage there. Another great advantage of learning R is R uses the same kind of language that you see in a lot of other computer programming languages. So if you know something about R, you're going to know something about a lot of other very important computer programming languages that you might want to learn in the future, right? So the skills you learn while learning R are very transferable. If you go to any like Fortune 500 company and you look at like what do they want their employees to know, they say things like Python. I have a friend that works for a important, I can't say on the internet, but an important computer company, and she had to learn Python for that. You know, everybody had to learn Python. It's a very important skill. SQL, another very, very important skill. Tableau, very important for producing data and spreadsheets for and graphs for maybe some customers that you have if you're working, you know, as an IO psychologist or something along those lines. All of those use the same kinds of logic and some programming techniques that you learn from R. So while SPSS and might not transfer as well to some other important software skills and computer programming language skills. R does, which is great. And the last thing, and this is one of the motivations that for creating this lab, or trying to think about whether or not I want to teach R in quantitative methods, is this is a very sought after skill. A lot of students will put something like Excel on their resume or their CV, but when has Excel ever made a difference as to whether or not someone ends up in graduate school or whether or not someone gets a particular job, right? Everybody puts Excel on their resume or CV. You could put SPSS there, and that's okay. But I would argue that that probably isn't doing much for you. However, if you could put that R either on your CV or on your resume, I think that's going to look really good when you're applying to some companies. They're going to know that you are pretty savvy when it comes to technology. And it's going to look great for graduate school. Okay, that's quite the feather in your cap. So I think that it would be pretty helpful to have this kind of knowledge. Okay, moving on. So you download R, and then almost everybody, the second thing that they do is they download RStudio, and they always work within RStudio and not base R. So why would we use RStudio instead of base R? Let me, if you don't mind, open up base R and RStudio for you. So here's base R. Doesn't look very attractive, right? If I want to open up a script, I have it here. It's pretty bare bones, not much I can do. I can move these windows around. But not the most helpful of programs. You can do everything here. It just is going to make things a little bit more difficult for you. It's not as user friendly. So let's go into RStudio. Okay, here we go. So we've got 4 panes here. There's lots of things that we can click to help us out. We can look at data lots of different ways. And we're going to learn what a lot of these functions do and how RStudio is different from base R. So let me talk a little bit about those advantages. So to kind of contrast the two, here's the analogy that I'm going to use. So base R is kind of like the engine of your car. The engine of your car is what ultimately gets the car to move. But if you look under the hood, it's a little bit confusing. It's not super user friendly to get this thing operational. You have to have a decent amount of knowledge to get it to work. RStudio, on the other hand, everything is easily displayed, and you can tell what's working and what's not working with the engine. You can easily command the car to move in a certain direction or start up, whereas that might be a little bit more difficult if you were just messing with the engine. So overall, RStudio is going to be easier for us to work with. It's going to be easier to see things. The usability is going to be much better. But let's go into some of these specifics. So the workspace for RStudio is going to be more intuitive. It's going to have a 4-pane layout, 4 different panes that we can do different things with. It's more intuitive than what's going on with base R, where you can kind of move those windows around, and sometimes they're open, sometimes they're not open. RStudio is going to make coding easier. It's going to color code certain things. It's going to have auto completion for certain functions and certain variable names, which is going to make things much easier for you. And you're less likely to make a mistake in coding because it's going to suggest what the correct way to do it is. Also, the help function is much better with RStudio, but that's one of these ones later, so I'm skipping ahead. Another great thing about RStudio, is you're able to use R project files. R project files are a way that you can share what you've done in R with other people. Um, they're incredibly helpful in terms of organizing everything in R. You can create a project file, and then you can have all of your particular data sets and all your particular code for that kind of bundled into one location. And you can send that to somebody, and they can run it, and it would be completely usable for them. Whereas if you're not using a project file, your computer is using code based off of your particular computer and where your directory is for your particular RStudio. So if somebody else gets your R script and it says, look into Dr. Harrison's My Documents folder, they don't have a My Documents folder. And so the code might not work. So our project files are going to be helpful for that, with everything being self-contained. The help tutorials and documentation for RStudio are excellent, and it's quite nice to see, oh, what does this function do? Oh, okay. You can find that quite easily in RStudio. Not as easy and not as user-friendly with base R. R packages, something that we're going to talk a lot about. R packages are they're some code that somebody has created for R. It could be anybody. It could be a quantitative psychologist. It could be an IO psychologist. But they come up with a package, and then they're going to submit it to the R server. And if you think that that code is going to be useful for you, you can download that package and use their code to help analyze your data. Finding R packages and implementing them is very easy in RStudio. You can look them up quite simply. There's a lot more advantages to RStudio, but I didn't want to overwhelm you guys in the beginning, so we'll just leave it at that. Okay, so how do you download this stuff? Well, the easiest thing to do is just to Google R, but you can go to the rproject.org, go to that website, and you can download base R. So one interesting thing about R is that all of these R packages and R is stored in servers all across the globe. And the network of these servers is called CRAN, which is Comprehensive R Archive Network. So anytime somebody wants to upload something to R, it goes to all of these different servers, and anybody that wants to use these particular statistics can access any one of these servers, download the code, and do their statistics. All right. So the particular server you connect to, you can select which one. My advice would be to select a server that is close to kind of where you live. So for those of us in North Georgia, there's one at Duke, there's one at Oak Ridge, Tennessee. Ultimately, it doesn't matter that much, but when you're downloading one of these R packages, it might be a little bit quicker if you select the one at Duke or the one at Tennessee. But for the most part, it's fairly quick, so it shouldn't matter. But just, word of advice. Okay. For these slides, for this lab, the current version of R as of the end of April is 4.6.0. And Base R always has a really cool name for their versions. So the current version is because it was there. So download that first. You need to download that before you can download RStudio. And again, I'd say just Google RStudio and it will show you how to download it. But here's the link in case you're interested. At the time of creating the slides, here's the current version of RStudio. For those of us at UNG, the software portal has both Base R and RStudio, but UNG our IT doesn't always update that software as soon as an update comes out. So I recently pinged them to update our company portal with the most up-to-date versions of the software. But if you grab those, it might not be the most up-to-date versions. That doesn't mean that they're not going to work. They would work still, but for some of the most recent packages, they might not be as effective. There might be some benefits for having the most up-to-date versions. Okay, so that's enough downloading and convincing you that this is a worthwhile endeavor. Let's look at the basic layout of RStudio. As I mentioned before, there are 4 panes in the upper left, bottom left, upper right, bottom right quadrants. So let's first look at the top left quadrant of RStudio. So this is going to be the source pane. This is where you're going to write your script. This is kind of the code that you're going to save and run to do your statistics. This is also going to contain like a viewer version of our data file when we're messing with data files. And we'll see that not in this lecture or lab, but in another one. You can, if you're familiar with SPSS, you can kind of think of this as your syntax file, right? It has all the code that you're going to run. It has a record of this so that you can look at it later. In the bottom left, we have the console pane. This is where the heavy action is taking place. This is where our code is going to be executed. So after we save our script, when we run it, it always runs on the console. If we don't want to save or create a script, we could just type it in the console and it would work. The only downside is it's not going to be saved for later on. Okay. The way that I kind of think about the difference between the source pane and the console pane and the difference between our script and the R console is our script is like a recipe card. It has the steps that we're going to take to analyze our data, to manipulate our data, to clean our data, to organize our data, and the statistics that we're going to run. And we can save this and use this recipe card as many times as we want to in the future. And hopefully, whatever it is that we're cooking is going to be exactly the same every time that we do this. But this is not actually cooking it. Something else has to happen before we cook it, right? Or we create whatever it is that we're cooking or baking. So we have this R script. We can save it. We can write it down. But ultimately, we have to run it on our console. Right, our console, this is like the stove. This is like the oven where we're actually cooking, we're actually baking the thing. Now, we could follow the recipe card when we're cooking something, or we could just go off willy-nilly and just start throwing spices and, maybe we heat it up for 5 minutes, maybe we do it 10 minutes. And that might work, right? But the downside is we're never going to know what we did in the future. Right? We might have a magnificent souffle, but someone says, "Hey, how did you make that souffle?" And you say, "I don't know. It's delicious though." Or maybe it's not delicious, So you could just wing it and you could do that. And that's fine. And there's some advantages to doing that. But you're not going to have that for posterity. Okay. So again, the metaphor is we're writing it down so we can save it for the future, and it's always going to be the same. But ultimately you have to run it. When it runs on the console. And we could just run things on the console, but they're not going to be saved for posterity. All right, makes sense? Okay, hopefully. In the top right, we're going to have the environment and history pane. This is going to have our data sets. So it's going to have some properties of the data sets that we are working with. So how many subjects are in the data set, for instance, how many variables there are, what kind of variables there are. That's going to be in this environment pane. It's also going to have a history of the commands that we've run in this pane as well. We'll mess with this one a little bit today, but we'll mess with this a lot more in the future. And the bottom right does lots of things. We could call it the output pane, but it does lots of things. So it has kind of the folders with our data in it. So like File Explorer, it's very similar to File Explorer, and we can have what data files that we have. We can look at our plots in this output pane, and we can also manage packages. So if we want to add a package, we want to see what our packages are active, that's in this output pane. And help and documentation is going to be in this bottom right pane as well. So here is what RStudio might look like. We've got these 4 panes. Let's go over them. So we've got the script up here. That's our source pane. In the bottom left, this is what happens when you start up R. It has this language here. This is the console pane. We'll be working a lot with that today. In the top right, we've got the environment and history pane. Right now, this person has 2 variables. One's named A, one's named B, and it has the values of those here. And we have this bottom right pane that's in the File Explorer mode here. This is the output pane. And we could click and look at plots. We could click and look at packages as well in this output pane. Just to give you another view kind of the same thing, here's another individual using RStudio. We've got the source, the pane up here, and their script file. We've got the console in the bottom left. We've got the environment and history pane in the top right. And ooh, look at this nice scatter plot here in the output pane in the bottom right. Let's go to my RStudio so you can kind of see what's going on here. Again, maybe when you open it up, it doesn't have the script open just yet, so we can exit out of that. This might be what it looks like when you first open RStudio. If I want to have that script pop up, I just go to New File and go to Script, and there it is. We're not going to be messing with the script today. Again, we're going to start easy, and we're just going to mess with things in the console. If I want to get rid of what's in the console right now, I'm going to go and click this little sweep and clear that console out. So we'll be messing with this for the next little bit. Here is kind of my files and my documents here. Let's start. Okay, that's enough talking about R. How about actually doing it? Again, I'm going to start very basic. Maybe you'll be bored. Tell me if you're bored. Tell me if you're overwhelmed. I really want to know that. But we're going to start off very, very basic. And in case you're interested in finding a good book on R, there is a free PDF of R for Data Science online that's really, really good. It's fantastic. It is a little bit overwhelming if you haven't had any computer experience before, but strongly recommend that you check that out. So again, let's start with the absolute basics. We're going to use R, in particular, the console pane as just a fancy calculator in the beginning. So let's just do some basic arithmetic. So we can use the plus sign for addition. We can use the minus sign for subtraction. We can use the asterisk for multiplication and the caret symbol for exponents. I don't have it here, and I need to add that to my slides, but you can use the slash key for division. So let's just kind of see what that looks like here. So if I just want to do some very basic math, 2 plus 2, and it's going to return the value of 4. You'll see over here this 1 in brackets. This is just an index for our output. So this is just telling us that line 1 of this output, we have 4. All right, we can do a little bit of subtraction and get a value. If I want to do some multiplication, I use the asterisk. If I want to use some division, I can use that slash key. And if I want to use an exponent or calculate an exponent, I can use that caret key right there. All right, so simple enough, but you've got a calculator. Why would you need R to do that? So let's see what else R can do. One thing before I move on is that spacing doesn't really matter when we're doing these basic math calculations, as long as there's not a space within, a variable or a function, and we'll talk about those a little bit later on. Doesn't matter how much space there is. So I'm doing 2 plus 2 in a variety of different ways. It always works out. I always get 4. It is important to remember here the order of operations. Parentheses, exponents, multiplication, division, addition, and subtraction. You remember PEMDAS. One of the first things that you learn when you're doing pre-algebra, and very important for statistics as well. So if I were to put this into the console, it would do the parentheses first. This would be 3. Then it would go to the multiplication. 4 times 2 is 8. And then it would go through the addition, right? So 2 plus 8 is 10. 10 minus 3 is 7. I should get 7. And that's what RStudio comes up with. All right. So let's get a little bit more complicated. Let's do some terminology. So when we use the term object in R, we're referring, it could be a number, it could be a function, an object could be a data set that we're working with. In the R community, there's the saying that everything in R is an object. So everything that we're really working with in R, we might call an object. Let's look at a very basic object, a variable. So a variable you can think of as, and also let me back up a little bit. When I use the term variable, when I'm talking about like a statistics package, computer program, it means something a little bit different than we talk about a variable in a psychology class. In psychology class, we're talking about like independent variable versus dependent variable. Variable is a kind of box in computer programming language that we can assign any value we want to it. We could say that we want it to be 3. We could say that we want it to be 4. We could change it, but it's a something that we store a particular value to that variable, so that we can easily access it, manipulate it, and update it later. If we want to assign a particular value to a variable in R, we're going to use this leftward arrow. And to create that leftward arrow, I'm going to do the less than sign and immediately do a hyphen right after this. So let's say that I want to create a variable for the number of children that I have. So I'm going to create a variable. I'm going to call it number of children. And I'm going to have this leftward arrow here. And then I'm going to put 2. So I'm going to assign the value of 2 to number of children. So let's go ahead and do this in RStudio. I'm going to clear my console, number of children, leftward arrow 2. Now notice here that I'm not using spaces between number of children. If I did that, it wouldn't work. I'm using that underscore. I could just get rid of the underscores and have no spaces. I could use dots. Either of those is fine. But I can't use spaces. It won't work out if I do that. So notice what happens when I press enter. So it doesn't seem like anything happens in the console, but you will see up here in the environment tab that it now says I've got a variable called number of children, and the value of that variable is 2. All right. This is an advantage of RStudio compared to base R. I've got this environment that I can kind of look at and see what's going on. All right. I could call this variable a little bit later on. So let's say I want to know what number of children is. Oh, look, RStudio does something wonderful. It's guessing that this is the variable that I want to work with, which is true. So I can just click that. If I press enter, it's going to tell me the value of number of children, which should be 2. All right. All right. We're starting to get cooking here. We're starting to make some progress. All right. Okay. I can use this variable later on to, manipulate it somehow. So let's say that I want to buy tickets to a movie for both of my kids. And I know that a ticket to the movie for kids is $15. And I have to buy it for both of my children. So I'm going to multiply the number of children that I have by $15 to see how much money I'm going to have to spend at the movies. Boom, and it's $30. So I can use this variable in the future. Couple of things about this variable before I move on. Um, so one, ooh, uh, yeah, let's talk about that first. One is you see that it's a pretty long variable. That's not great. Okay. Typically, you want to work with a variable that's a little bit shorter than this because it's a little bit easier to use. Um, but I'm being pretty explicit just for teaching you guys. Um, the other thing that I'll mention is again, I can't have the spaces, so I can use the underscores, I can use dots, I can get rid of the spaces entirely. Um, oh no, I need to change this variable because I'm having another child in August. So how are we going to change this variable? Let's see how I could go about doing this. So one thing that I could do, well, let's clear this out, is I could just, number of children is now going to be three, and that's perfectly fine. But maybe I don't know how many children I currently have, and I just know it's one more than what I currently have. So I'm going to change this. Number of children is now going to be number of children plus one. Does it matter that I didn't put a space there? No, it doesn't matter. Let me add a few more spaces just for laughs and giggles. Shouldn't matter. Let's press enter and see what happens. Doesn't look like it changed here any, but look up here. It has changed. It's now three. You don't believe me? Let's type in number of children. When I do this, I should have three. Bang, doing good. Okay. Um, I don't just have to, put in a simple value. I couldn't have a calculation when I assigned a value to a variable as well. So maybe I have something like 17 minus 5. And when I, call x again, it's going to give me what the answer is there, which is 12. Okay, that's going to work too. All right. Yeah, I already talked about a couple of things. All right. So yay, variables. Okay. Variables have a variety of data types that they can take. There's a number of different data types, but I'm going to talk about the two most basic ones that you're going to use the most. One is a numeric variable. Numeric variables we use for numeric data, and they can have decimals or not have decimals. The old school term for this kind of data type is a double. Where that comes from is like way back in the day for computer programming. I guess not way back in the day. But a double variable would have double the amount of computer memory. It would have 8 bytes instead of 4 bytes. And so that's why it was called a double. So that's what that's where the double comes from. But we use this for our numeric data. The other kind of data type that we have is a character. So these are letters. These are text. Another word for this, and the term that SPS uses is string data. So if you hear about a string variable, that's the same thing as a character variable in R. So to create a character variable, we might have something like I love statistics or cognitive psychologists are cool, and we have to put that in either single or double quotation marks. All right. So let's create a variable and let's call that variable your mom. And what do we want to say about your mom? Again, we need to make sure that we have that leftward arrow here. Let's say your mom is a nice lady, because I'm sure that's true. Let's click enter. Boom. And again, we have up here the value, your mom, and she is a nice lady. And if I were to call your mom, uh, that's pretty funny. Let's press enter. What happened? She's a nice lady. Okay, fantastic. Let's go back. What happens if we try to add your mom to number of children? We get this error message that pops up. I won't do it, but an error message will pop up. Why does it pop up? Well, number of children is a numeric variable. your mom is a character variable, and they have two different data types. So they're not going to work together. And it's going to be a problem, and it's going to return an error message for us. Okay. All right. So we talked about different data types. Now let's talk about different data structures. So, data structure, what that means in computer science language is it's the format of our data. Um, so, it's the format of our data, how we store it, how it's organized, how we can manipulate it. And there's some basic data structures in R. We're going to use the easiest version in the beginning, and then we're going to go to some things that are a little bit more complicated, but a lot more useful. The most simple data structure is a vector. A vector is a one dimensional data structure. Um, so it's just going to be a bunch of numbers, is essentially what a vector is. Um, so it's a one dimensional data set, and it's going to have the same data type for every data point. So we would say that a vector has homogeneous data types in it, or the data types are homogeneous in vector within vectors. So this is the most basic data structure within R. Okay, so let's create our first vector, and our vector is going to contain the number of times our x's, each one of our x's has been arrested. All right. So if we want to create a vector in R, we're going to use the lowercase letter c and put in parentheses those data points. So let's do that. Okay. So apparently my x's, not my real x's, all my real x's are really nice, but let's put this here in our studio here. So 14024. Let's do that. I am going to clear my console. Not only that, I'm moving to something different, so I'm going to clear my environment as well. Again, I'm going to hit this little sweep. Oh, don't want to remove everything. Yes. So I'm going to create a vector. It's going to be called my x's. Remember, I can't have a space there. I need to include the arrow. I need to have C. I need to have in parentheses 1, comma, 4, comma, 0, comma, was it 3? No, 2, comma, 4. Does the spaces here matter? Not really, but I'll keep it like this. Okay. So when I press enter, it's not going to do anything in the console, but it should appear in my environment pane. Boom, there it is. Another thing that you get in the environment pane is gives us the the data type, which is numeric. We just talked about that. And we've got 1 through 5 different values here. Okay. 14024. Okay, beautiful. Just for laughs and giggles, let's call this my x's. Again, RStudio is going to auto complete what it thinks I want. Boom, there it is. Okay. Um, let's mess with this a little bit. Okay. How do I want to mess with this? Okay. Okay. First thing that I want to do is I want to index the vector. What does indexing mean? Indexing means I want to only look at some of the data in my vector. So I only want to look at the first item. I want to look at the second item. So let's do that. To do this, I'm going to use brackets. So let's go and look at maybe the first one of my x's, right? So I'm going to do my x's, and then I'm going to put in brackets. And look, RStudio auto completes and has that second bracket for me. So I want to return the value of my first x. So this should be 1, right? That's what the first value is. Let's see if that's correct. Boom, it's 1. Yay. How about my third x? Let's do that. Boom, boom, boom. No, bad, Tyler. That's what I think it's going to be. I should return 0, right? Bang. Okay, cool. Let's say that I want to look at a range of values in my vector, and I want to index a range of them. So let's do that. So what I'm going to do now is I'm going to put brackets, but let's say I just want to look at the first three. I'm going to put 1, I'm going to put a colon, 3. And so what this should return is the first three values of the number of times my x's have been arrested. So x1, 2, and 3. That's what it does. Good job, me. All right. So we talked about what the brackets do. We talked about what the colons do. Um, this can get more complicated, but again, we're starting off basic. We're just doing some basic things, learning a little bit about some basic data structures, learning what the word index means, learning about variables. Okay. Oh no, there's trouble. What trouble is there? Is the trouble that maybe I don't know how to choose who to date because it seems like they get in trouble with the law frequently. Let's say that all my exes got together and they robbed a liquor store and they all got arrested. Okay, now I got to change my vector. Oh no, how do I change my vector? Let's go and do that. So, I'm going to clear this. So, what happens if I put my x's and I'm going to add a 1 to that? Okay. What this is going to do is it's going to tell me the number of times that each of my x's got arrested and add 1 to each one of them. So let's press enter. Bang. Okay. So this is 1 plus every single one of them. Okay, that's great. Let's look at something real quick. Let me call my x's again. Oh no, it's 14024. It hasn't changed, right? That's because I didn't store this as the new variable. If I wanted to store it, remember the way that I would go about doing this would be the new my x's would be my x's plus 1. That would do it, and it would change it. I don't want to do that right now, though. So I'm gonna erase that. Gonna go back to the slides. Okay, cool. I hope you're learning. All right. So last couple of things here. So I've already used the term R package. What do I mean by R package? So an R package is a collection of code, data, documentation that someone wants to create for R. They're going to create it and they're going to put it on CRAN. And anybody that wants to download it and use it for their own data can do it. All right. So when a new psychologist or a new statistician develops a new statistic, one of the first things that they do nowadays is they put that on R, right? If it's going to be behind a specialized software that costs lots of money, no one's going to use it. Well, people will use it, but it's going to be harder to catch on. But if you're an academic, uh, ultimately you don't really care that much about money. I mean, think about it. Like, how much money do us professors actually make? We care about the science, so we want people to use it. So get it out there. Okay, that's what the philosophy behind R is all about. Okay, um, with our packages come functions. Functions are a specific block of code that performs a task. So let's talk about our first function. Our first function is going to be calculating a mean. But before we get to that, let's do a few more terms. So the information that goes into the function, we're going to call an argument. So if our function is mean, the argument is going to be the data set that we want to calculate the mean of. Okay. And what's going to be calculated by putting the argument into the function is going to be the return value. All right, so that should be what the mean actually is. So we're going to learn our first function, and our first function is going to be the mean. Yay. So let's go and do this. Okay, we're going to put in mean, And in parentheses, we're going to put the vector that we've been working with, my x's. All right. So mean, this is the function. My x's, this is the argument. I'm going to press enter. Boom, 2.2 is the mean, and that is my return value. All right, so that's useful. But what are some other basic functions that you should probably know about R? Okay, so mean, it finds the mean. That's pretty useful. STR, what does that stand for? That stands for structure. So that's going to give me something about the layout of the particular variable, the particular vector, the particular data structure I'm looking at. So are there numeric variables in there? Are there, how big is that data structure? That's going to be pop up when I use str. Sum is going to add everything up. Sort is going to sort all of the values. So here you can see, and do this on your own. But when I do this, I get the mean, the structure, everything's numeric, 1 to 5. Here's what's in that particular vector. Remember, this is the same thing that's in that environment pane. Sum, if I add everything up, gives me 11. Sort, and here they are in ascending order. All right, those are pretty useful. Let's learn a few more useful functions. So we have minimum and maximum. Those find the minimum and maximum values in our data set. Median, those find the median in our data set. Hopefully, this is pretty intuitive for you guys. Okay, you know these descriptive statistics. All right, let's say that you want all the descriptive statistics at the same time. Summary does a good job of this. If you do summary, it's going to calculate the mean, median, minimum value, maximum value. And not only that, it's going to calculate the first and third quartile as well. Way more than you probably wanted, but that's great. And SD, what do you think SD does? Oh, it calculates the standard deviation. I bet you could see that one coming a mile away. Let's look at these. Bang. Okay. So we've got the minimum 0, the median is 2, and we have all of this lovely descriptive statistics information if we use the function summary. And again, remember my x's, that's what I would call the argument, and these are the return values. And there's the standard deviation. Now, if you are an astute quantitative methods student, if you're looking at this, maybe you're thinking to yourself, well, what standard deviation is it? Is it the population standard deviation that has n as the denominator? Or is it the standard deviation for samples that we use most of the time that has n minus 1 in the denominator for calculating standard deviation? So good question. How do we figure that one out? Well, we could calculate it by hand and then compare it to what R is doing, but there's an easier way to do that. Let's use the last function that we're going to talk about today. And the last function that we're going to talk about today is help. So we're going to use help, and the argument for help is going to be the function that we're interested in. So here we're going to do SD, and it's going to pull up documentation about what R is actually doing, so we can figure out which one we're looking at. Let's do that. So I'm going to clear this. I'm going to type in help, and in parentheses, I'm going to put SD. I'm going to press enter. And here in the bottom right in the output pane, it's going to give me a lot of information, and a lot of this isn't super relevant for me. But as I go down, in details, like var, which is the function for variance, this uses the denominator n minus 1. Oh, so it is the standard deviation that I want. Hooray. That's the standard deviation that we use most of the time. That's the unbiased formula for standard deviation. Okay, fantastic. So that's all I wanted to teach you today. But before we move on, I wanted to give you a little bit of a challenge to make sure that you're understanding what it is that I'm talking about. So here's what I want you to do. I want you to create a new vector for my x's that we've been working with. And I want you to create a new vector called my x's underscore z. And this is going to contain the z scores of the number of arrests that my x's or your x's, it's going to convert those scores to z scores. Okay. And try to do it in one line of code. And you should know this, but this is how you calculate a z-score, right? It's the score minus the mean minus the standard deviation. So at this point in time, you should pause the video and try that out on your own. That's the best way to learn. But for me, I'm going to move on and show you how to do this real quick. So let's do that. Well, before I show the answer, let's do this here. All right, so the new one is going to be called my x's underscore z. And what's it going to be equal to? Well, it's going to be equal to my x's minus the mean. And how do I calculate the mean again? Oh, I use mean and I put my x's here. And the last thing that I do is I divide by the standard deviation. Divide by standard deviation of what? My x's. Am I done? No, because I haven't thought about order of operations. Okay. The standard deviation would just be divided by the mean if I ran it right now. So I need to put this in parentheses. So each value of my x's minus the mean, and then take that value and divide it by the standard deviation. Okay. So I'm going to press enter. We're going to see up here that it's going to have those z-scores. And if I wanted to show you those z-scores again, bang. Okay. And there it is. Okay. So that's lab one. Couple of things. Let me know what you thought about this lecture / lab, if you don't mind. And you guys can put that in the YouTube comments if you want to. You can email that to me. The other thing is, if this was helpful for you, let me know, and also let me know what you would like to see me do in R. Okay, I know. Again, very, very basic stuff right now. Okay. I'm going to move on and get a little bit more complicated. But if there's stuff that you're particularly interested in, please let me know. Anything about, how to clean data, how to manipulate data, how to, look at only a subset of your data. Which of those skills are you most interested in? What are some statistics that you are particularly interested in doing in R? But yeah, any feedback would be wonderful. Okay, I appreciate it. I hope this was helpful for you. Please give me feedback, and I hope you have a fantastic day. Bye-bye.